7th grade Open Up Resources, Illustrative Math. Unit 7, Lesson 1, Relationships of Angles. Key terms. Adjacent angles. Adjacent angles share a side and a vertex. In this diagram, angle ABC is adjacent to angle BDC. The side that these two adjacent angles share is line segment BC, and the vertex that they both share is located at point B. Straight angle. A straight angle is an angle that forms a straight line. It measures 180 degrees. Right angle. A right angle is half of a straight angle. It measures 90 degrees. Problem number 1. Here are questions about two types of angles. Draw a right angle. How do you know it's a right angle? I know it's a right angle because a square fits perfectly inside it. What is its measure in degrees? A right angle's measure is 90 degrees. Draw a straight angle. How do you know it's a straight angle? I know it's a straight angle because I drew a straight line with an angle of 180 degrees. What is its measure in degrees? Let's take a look at why a straight line is actually 180 degrees. Let's start with a new angle. It's represented with a pink color. Let's start at 0 and open this angle up until it reaches 180 degrees, and you'll see that it makes a straight line. And there it is, a straight line that spans 180 degrees. Problem number 2. An equilateral triangle's angles each have a measure of 60 degrees. A. Can you put copies of an equilateral triangle together to form a straight angle? Explain or show your reasoning. Well, remember, a straight angle measures 180 degrees. I know that 180 degrees divided by 3 equals 60 degrees. This illustration shows that we could use 3 angles that each measure 60 degrees to form a straight angle, measuring 180 degrees in total. The answer is yes. 3 equilateral triangles put together can form a straight angle. B. Can you put copies of an equilateral triangle together to form a right angle? Explain or show your reasoning. Remember, a right angle measures 90 degrees, and we just figured out that an equilateral triangle measures 60 degrees. Let's put one equilateral triangle inside here and see how much space it takes. Just one equilateral triangle takes up 60 degrees out of the right angle's 90 degrees. Adding another copy of the equilateral triangle would bring the total measure to 120 degrees, and that would be too much. So the answer to the question would be no, because one equilateral triangle is not enough, and 2 equilateral triangles is too much. Problem number 3. Here is a square and some regular octagons. In this pattern, all of the angles inside the octagons have the same measure. The shape in the center is a square. Find the measure of one of the angles inside one of the octagons. Here's the pattern including 4 octagons, and the shape in the center is a square. Squares are made up of 4 right angles. I've highlighted one of the right angles in blue. We know that the measure of a right angle is 90 degrees. And we know that the measure of a straight angle is 180 degrees. This yellow line represents a straight angle of 180 degrees. Angle ABC equals 180 degrees minus 45 degrees, because the yellow line cuts right through the square, cutting 90 degrees in half, and half of 90 is 45. 180 degrees minus 45 degrees is 135 degrees. Each angle inside an octagon measures 135 degrees. Problem number 4, from 7th grade Unit 6, Lesson 17. The height of the water in a tank decreases by 3 5/10 centimeters each day. When the tank is full, the water is 10 meters deep. The water tank needs to be refilled when the water height drops below 4 meters. A. Write a question that could be answered by solving the equation 10 minus 35 thousandths times d equals 4. The 10 in the equation represents 10 meters deep. The negative represents a decrease, but 35 thousandths is 100 times smaller than 3 5/10. And the 4 represents the statement, the water tank needs to be refilled when the water height drops below 4 meters. One basic question that we could write would be, how many days can go by until the water tank needs refilling? B. Is 100 a solution of 10 minus 35 thousandths times d is greater than 4? Write a question that solving this problem could answer. Well, to see if 100 is a solution, let's test it out with d equaling 100. We can rewrite the inequality as 10 minus 35 thousandths times 100 is greater than 4. If it is actually greater than 4, then it would be a solution. 10 minus 3 5/10 is greater than 4. Well, let's see if that's true. 10 minus 3 5/10 is 6 5/10, and that's true. 6 5/10 is greater than 4. A question that can be answered by solving this inequality would be, after 100 days, would there still be enough water left in the tank that it would not need refilling? Yes, there is still enough water in the tank after 100 days. So at this rate of decrease, after 100 days, the tank would not have to be refilled yet. Problem number 5, from grade 7, unit 6, lesson 18. Use the distributive property to write an expression that is equivalent to each given expression. A. We can do this by multiplying the term on the outside of the parentheses by both the terms on the inside of the parentheses. Negative 3 times 2x. Negative 3 times 2x is negative 6x. Negative 3 times a negative 4, or negative 3 times minus 4. Well, that's a negative times a negative, and a negative times a negative is a positive. Another way to look at that is negative times a negative means the opposite of a negative, and the opposite of a negative is a positive. 3 times 4 is 12. So after using the distributive property, we can rewrite this expression as negative 6x plus 12. B. 1/10 times negative 90 plus 50a. Again, when we're using the distributive property, we're going to multiply the outside term by both the terms on the inside of the parentheses. 1/10 times negative 90, so that's going to be 10 times smaller than negative 90. That's negative 9. And 1/10 times the second term, and the second term is 50a. So 1/10 times 50a. That's going to be 10 times smaller than 50a. 10 times smaller than 50a is 5a. We need to add these two terms, but they're not like terms. So we keep it as negative 9 plus 5a. C. Negative 7 times negative x minus 9. This one can be a little tricky because we're multiplying a negative times a negative, and a negative times a negative is a positive, or the opposite of a negative is a positive. 7 times x is 7x. Again, we have a negative times a negative, or the opposite of a negative is a positive. 7 times 9 is 63. And again, we're down to two terms, but these two terms are not like terms, so we'll keep them separate. 7x plus 63. You can always tell by looking how many terms you're going to have in your final expression, just by looking at the terms here. We have one term with a y, we have another term with an x, and we have a term with no variable at all. So we're going to have 3 terms in our final expression. The outside term, 4/5, times the first term, 10y. 4/5 times 10y. I'll multiply these two terms in a minute. 4/5 times a negative x. 4/5 times a negative x is negative 4/5 x. They did this before the other term as well, but they put a plus sign ahead of a negative sign, and that really means plus a negative. An easier way to think about it is to say and instead of plus. So you can say and a negative. 4/5 times 15. 4/5 times 10y, or 4/5 of 10y, is 8y. 4/5 times 15, or 4/5 of 15, is 12. Now we're left with the three terms, 8y, a negative 4/5 x, and minus 12. So after using the distributive property, the expression reads 8y minus 4/5 x minus 12. Problem number 6 from grade 7, unit 2, lesson 3. Lynn's puppy is gaining weight at a rate of 0.125 pounds per day. Describe the weight gain in days per pound. I've decided to illustrate this in a chart. On the right-hand side, I have the days, numbered 1 through 8. On the left-hand side, I have the amount of pounds increasing by 0.125 pounds per day. On the 4th day, we have a half a pound. On the 8th day, we have 1 full pound. Every 8 days, the puppy gains 1 pound. And that's because 0.125 pounds is actually an eighth of a pound. So after 8 days, the puppy would have gained 8/8 of a pound, or 1 full pound. Seventh grade, Unit 7, Lesson 2, Adjacent Angles, Illustrative Mathematics. Problem number 1. Angles A and C are supplementary. Find the measure of angle C. Supplementary angles are two angles that, when added together, equal 180 degrees. We can rearrange these two angles so it looks like this. When we add angle C to angle A, it's going to total 180 degrees. 74 plus what number equals 180 degrees? 180 minus 74 equals 106. So angle C is 106 degrees. Problem number 2. List two pairs of angles in square CDFG that are complementary. Complementary angles are two angles that when you add them together, they total 90 degrees. 63 plus 27 equals 90, and 64 degrees plus 26 degrees is also 90 degrees. Those two pairs of angles could be angles DCM and MCD, and also angles FGM and MFG. B. Name three angles that sum to 180 degrees. Remember, sum means to add them up. Let's look at these three angles. Angle C, angle D, and angle M. We know that angle D is a 90-degree angle, and we know that 63 degrees plus 27 degrees is also 90 degrees. 90 degrees plus 90 degrees equals 180 degrees. So we can say that angles DMC and CMD sum to 180 degrees. Problem number 3 from 7th grade, Unit 6, Lesson 22. Complete the equation with a number that makes the expression on the right side of the equal sign equivalent to the expression on the left side. I'm collecting like terms. 5x plus 6x equals 11x. A negative 2.5 and a negative 3 equals a negative 5.5, or minus 5.5, equals what number times 2x minus 1? I just noticed that half of 11 is 5.5, and 5.5 times negative 1 equals negative 5.5. So we can replace this question mark with 5.5. 5.5 times 2x equals 11x, which is equivalent to the 11x on the left side of the equal sign. And 5.5 times negative 1 equals negative 5.5, which also matches the negative 5.5 on the left side of the equal sign. Now that the term on the right side of the equal sign equals the term on the left side of the equal sign, then we know that the missing number is 5.5. Problem number 4 from 7th grade, Unit 2, Lesson 4. Match each table with the equation that represents the same proportional relationship. To find the constant of proportionality for table A, we can do 8 divided by 2, and we know that 8 divided by 2 is 4, which means 2 times 4 equals 8. 3 times 4 equals 12, 4 times 4 equals 16, 5 times 4 equals 20. That means that the y value is 4 times the x value. Table B. To find the constant of proportionality, we can do 4.5 divided by 3. That equals 1.5. So 3 times 1.5 equals 4.5. 6 times 1.5 equals 9. 7 times 1.5 equals 10.5. And 10 times 1.5 equals 15. This means that the value for y is 1.5 times greater than the value for x. Table C. To find the constant of proportionality for Table C, we will divide 5.2 by 2. That equals 1.25. So 2 times 1.25 equals 5 over 2. 4 times 1.25 equals 5. 6 times 1.25 equals 15 over 2. And 12 times 1.25 equals 15. That means that the value for y is 1.25 times greater than the value for x. If you're not subscribed to my channel, please subscribe right now, and you can watch the next lesson. Thanks for watching, and I'll see you next time. 7th grade, Unit 7, Lesson 3, Non-Adjacent Angles, Illustrative Mathematics. Problem number 1. 2 lines intersect. Find the value of B and C. This angle that's 42 degrees is the same size as angle B, so angle B is also 42 degrees. We can use this information to help us find the value of C. A straight line is 180 degrees, which is half of 360 degrees. Just like in skateboarding, 360 degrees or a 360 is one time all the way around. And a 180 is half of a 360 or halfway around. Angle B plus angle C equals 180 degrees. So if we subtract 42 degrees from 180 degrees, we'll have the missing angle. Angle C is 138 degrees. Problem number 2. In this figure, angles R and S are complementary. Find the measure of angle S. Complementary angles add up to 90 degrees. So angle R plus angle S equals 90 degrees. Angle R is 62 degrees. So 90 degrees minus 62 degrees gives us the number of degrees for angle S. Angle S is 28 degrees. Problem number 3. If 2 angles are both vertical and supplementary, can we determine the angles? Is it possible to be both vertical and complementary? If so, can you determine the angles? Explain how you know. Complementary angles add up to 90 degrees. Supplementary angles add up to 180 degrees. Vertical angles are a pair of opposite angles formed by intersecting lines. Vertical angles are congruent. Here are a pair of intersecting lines forming vertical angles and supplementary angles. If this angle is 90 degrees, then this angle would also be 90 degrees. Add the angles along the straight line and the sum is 180 degrees. So 90 degrees plus 90 degrees equals 180 degrees. So this angle would be 90 degrees. And if this angle is 90 degrees, then this angle would also be 90 degrees. The answer to the first question is yes, we can determine the angles. The next question says, is it possible to be both vertical and complementary? Complementary angles add up to be 90 degrees, and vertical angles are identical. So what number plus itself equals 90 degrees? 45. So with this vertical line, we can see that this 45-degree angle is a vertical angle and complementary to the 45-degree angle, which is also a vertical angle. Only a 45-degree angle can be both vertical and complementary. So that answer is also a yes. And the third question says, if so, can you determine the angles? And the answer is yes. We determined that these angles are 45-degree angles, and my explanation is in my diagram. Here's a written response to the first question in problem number 3. You can pause the video if you like. And here is a written response for the second part of number 3. Pause the video if you need to. Problem number 4 from 7th grade, Unit 6, Lesson 22. Match each expression in the first list with an equivalent expression from the second list. A. 5 times x plus 5 times 1. That's 5x plus 5. And negative 2x plus 11x. Collect like terms. 5x minus 2x. That's 3x. And positive 5 plus 11. That's positive 16. 3x plus 16. Expression A is equivalent to expression 4. B. Collect like terms. 2x plus 1x. That's 3x. And a positive 2 plus 5. That's positive 7. 3x plus 7. That's going to be equivalent to expression 2 because half of 6x is 3x and half of 14 is 7. C. Collect like terms. We have a negative 3/8 x and a positive 5/8 x. That's the same as 5/8 x minus 3/8 x, or 2/8 x. Remember, 2/8 can be simplified or reduced to 1/4, so this becomes 1/4 x. The two remaining terms are negative 9 and positive 1. Negative 9 plus 1 equals plus a negative 8, or negative 8. So 1/4 x minus 8. This expression matches expression 1. Expression D. I notice this looks a lot like expression 5, but expression 5 says plus a negative 5.53, or and a negative 5.53. So expression D matches expression A. Expression E. The greatest common factor is 11. So we can put 11 on the outside of the parentheses. 11 times what number equals 99? Well, 99 divided by 11 is 9. So we can substitute that question mark with a 9. 44 divided by 11 is 4. So we can substitute that question mark with a 4. Expression E matches expression 3. Problem number 5 from 7th grade, Unit 6, Lesson 19. Factor each expression. A. 15a minus 13a. Their greatest common factor is a. So we can put a on the outside of the parentheses. 15a divided by a is 15. So we'll substitute the first question mark with 15. And 13a divided by a is 13. So the factored expression reads a times 15 minus 13. B. The greatest common factor is negative 6. So we can put negative 6 on the outside of the parentheses. Negative 6x divided by negative 6 is positive 1x, or x. Negative 18y divided by negative 6 is a positive 3y. So the factored expression reads negative 6 times x plus 3y. C. The greatest common factor is 9, and a. So we can put 9a on the outside of the parentheses. 36 divided by 9 is 4, so we can substitute this question mark with a 4, and we'll bring down the b and the c. 54 divided by 9 equals 6, and we'll bring down the d. Now the factored expression reads 9a times 4bc plus 6d. Problem 6 from 7th grade Unit 6, Lesson 17. The directors of a dance show expect many students to participate, but don't yet know how many students will come. The directors need 7 students to work on the technical crew. The rest of the students work on dance routines in groups of 9. For the show to work, they need at least 6 full groups working on dance routines. A. Write and solve an inequality to represent this situation, and graph the solution on a number line. Here I've written and solved an inequality. Pause the video if you need to. And here's the graph for the inequality. B. Write a sentence to the directors about the number of students they need. The directors need at least 61 students, with 7 of them working on the technical crew, and the other 54 working in 6 dance groups of 9. Problem number 7 from 7th grade Unit 2, Lesson 5. A small dog gets fed 3/4 of a cup of dog food twice a day. Using D for the number of days and F for the amount of food in cups, write an equation relating the variables. Use the equation to find how many days a large bag of dog food will last if it contains 210 cups of food. I could start by making a table. On the left-hand side, I have cups of dog food. On the right-hand side, I have number of days. The dog gets fed 3/4 of a cup of dog food twice a day. So that would be 3/4 plus 3/4 equals 6/4, which is equivalent to 3/2 or 1.5 cups. That means that the dog eats 1.5 cups of dog food each day. I'll use the fraction 3/2 so I can avoid using mixed numbers. The amount of food divided by 3/2 equals the number of days. In this example, 3/2 divided by 3/2 equals 1, so that would be 1 day. This also means that 3/2 times the number of days equals the amount of food. They want to know how many days 210 cups of dog food will last. 210 cups divided by 3/2 equals 140. So 210 cups of dog food will last 140 days. I've written this out on the next 2 slides, so you can pause each of them if you have to. Please make sure you're a subscriber to my channel. I'd appreciate it. And you can watch the next lesson. Thanks for watching, and I'll see you next time. Seventh grade, Unit 7, Lesson 4, Solving for Unknown Angles, Illustrative Mathematics. Problem number 1. M is a point on line segment KL. NM is a line segment. Select all the equations that represent the relationship between the measures of the angles in the figure. A equals B. Angle A is much shorter than angle B, so it's obvious that angle A does not equal angle B. B. A plus B equals 90. Angle A plus angle B equals 180 degrees, so angle A plus angle B does not equal 90. C. B equals 90 minus A. Since A plus B equals 180 degrees, then B equals 180 degrees minus A. So B does not equal 90 minus A. D. A plus B equals 180. Yes, that's true. We've already identified that. A plus B equals 180 degrees. E. 180 minus A equals B. Yes, that's true, because a plus b equals 180, so 180 minus a equals b, just like b equals 180 minus a. F, 180 equals b minus a. No, that's not true, because we know that 180 equals b plus a, not b minus a. Problem number 2. Which equation represents the relationship between the angles in the figure? The figure shows 1b plus 88 plus 1b. That's equivalent to 2b plus 88. So we know it's not equation A or equation B. Look at the figure one more time. Look at the straight line. 1b plus 88 plus 1b. That totals 180 degrees because that makes a half circle. So the equation that represents the figure is equation D. 2b plus 88 equals 180. Problem number 3. Segments AB, EF, and CD intersect at point C, and angle ACD is a right angle. Find the value of G. Look at the figure. Angle ACD is a right angle, so we know that's 90 degrees, because right angles are 90 degrees. 90 degrees plus 53 degrees plus G equals 180 degrees. 180 degrees makes a half circle, and as you can see, this is a half circle. To find G, we can do 180 degrees minus 90 degrees minus 53 degrees. G equals 180 minus 90 minus 53, which is 37. So G is 37 degrees. Problem number 4 from 7th grade Unit 6, Lesson 12. Select all the expressions that are the result of decreasing x by 80%. We can start with x, and then we're decreasing x by 80%. So that means that we can subtract 80% of x. So we can write x minus 80% times x, or x minus 80% of x. 80% can be written as 80 over 100. So we can rewrite this as x minus 80 hundredths times x. We can also write it as a decimal, which would be x minus 80 hundredths times x, and we can write it as x times 1 minus 80 hundredths. X minus 80% of x is equivalent to 20% of x. So that matches with A, 20 over 100 times x, because 20% of x can be written as 20 over 100 x. Expression B is also a match because we have x minus 80 over 100 times x. Expression C is not a match because that represents x as being equal to 80% of x, when we already know that expression A is correct, 20% of x. Expression D is also not correct because 80% of x is not the same as 20% of x, and 80 hundredths of x is not the same as 20 hundredths of x. Expression E is correct. In fact, we can rewrite the expression in red by moving the x to the other side. This is equivalent to 1x minus 80% of x, which would leave you with 20% of x. Problem number 5. From 7th grade, Unit 6, Lesson 8. Andre is solving this equation. He says, I can subtract 3 halves from each side to get 4x equals 11 halves, and then divide by 4 to get x equals 11 over 8. Kieran says, I think you made a mistake. A. How can Kieran know for sure that Andre's solution is incorrect? Andre's solution said x equals 11 eighths. So let's plug in 11 eighths into the equation for x. Doing it Andre's way, the equation simplifies to 11.5, not 7. B. To fix his mistake, he should use the distributive property to get 4x plus 6 equals 7. Then subtract 6 from both sides of the equal sign, and then divide both sides by 4. The value for x will be 1/4. Problem number 6. From 7th grade, Unit 6, Lesson 7. Solve each equation. A. Subtract 3/4 from both sides of the equal sign.
3/4 minus 3/4 equals 0. 9/8 minus 3/4 equals 3/8. Now you can rewrite it as 1/7 x equals 3/8. Multiply both sides by the reciprocal of 1/7, which is 7/1. That makes 1x, or x, and 3/8 times 7/1 is 21/8. So x equals 21/8. B. Subtract 2/3 from both sides of the equal sign. That leaves us with 1/5 x equals 5/6 and minus 4/6. 5/6 minus 4/6 is 1/6. We can rewrite the equation as 1/5 x equals 1/6. Multiply both sides of the equal sign by the reciprocal of 1/5, which is 5/1, and that leaves us with 1x, or x, and 1/6 times 5/1 is 5/6. So x equals 5/6. C. Subtract 2/3 from both sides of the equal sign. Now the equation reads 9/6 and negative 4/6 equals 4/3 x. 9/6 minus 4/6 equals 5/6. And then multiply both sides by the reciprocal of 4/3, which is 3/4. The value for x is 5/8. D. Subtract 7.9 from both sides of the equal sign and divide both sides by 0.3. 0.3x divided by 0.3 is 1x, or x, and 1.2 divided by 0.3 is 4. The value for x is 4. E. Subtract 8.78 from both sides of the equal sign and then divide both sides by 0.02. The value for x is 112.5. Problem number 7 from 7th grade, Unit 2, Lesson 5. A train travels at a constant speed for a long distance. Write two constants of proportionality for the relationship between the distance traveled and elapsed time. Explain what each of them means. If we divide 1.2 hours by 1.2, we'll get 1 hour. And since we divided time elapsed by 1.2, we need to divide distance by 1.2. So 54 divided by 1.2 is 45. This first constant of proportionality is 1 to 45. This means that in 1 hour, the train travels 45 miles. To find the second constant of proportionality, we need just 1 mile. So let's take 180 and divide it by 180 to get 1 mile. Now we need to divide time elapsed by 180. 4 divided by 180 equals 1/45. This constant of proportionality is 1 to 1/45. This means that it takes 1/45 of an hour for the train to travel 1 mile. Take a moment to subscribe to my channel if you haven't already, and you can watch the next lesson. Thanks for watching, and I'll see you next time. 7th grade, Unit 7, Lesson 5. Using equations to solve for unknown angles. Illustrative Mathematics. Problem number 1. Segments AB, DC, and EC intersect at point C. Angle DCE measures 148 degrees. Find the value of x. The sum of these three angles will equal 180 degrees. So x plus 148 degrees plus x will equal 180 degrees. X degrees plus 148 degrees equals 180 degrees. That's the same as 2x degrees plus 148 degrees equals 180 degrees. To solve for x, we'll subtract 148 from both sides of the equal sign. That leaves us with 2x degrees equals 32. The next step is we need to divide both sides by 2. And that leaves us with 1x degrees, or x, equals 16 degrees. So x equals 16 degrees. Problem number 2. Line L is perpendicular to line M. Find the value of x and w. W degrees plus 138 degrees equals 180 degrees. We need to subtract 138 from both sides of the equal sign. 138 minus 138 is 0, so on the left side of the equal sign we're left with w, and on the right-hand side of the equal sign we're left with 42 degrees. So we know that w is 42 degrees. Now we need to find the value for x. 19 degrees plus x degrees plus w, or plus 42 degrees, will equal 90 degrees. To solve for x, we need to collect like terms. 19 plus 42 equals 61. Next, we can subtract 61 from both sides of the equal sign, and we have x equals 29. X is 29 degrees. Problem number 3. If you knew that two angles were complementary and were given the measure of one of those angles, would you be able to find the measure of the other angle? Explain your reasoning. Yes. If two angles are complementary, it means that the sum of their measures is 90 degrees. If we are given the measure of one of the angles, we can find the measure of the other angle by subtracting the given measure from 90 degrees. Problem number 4, from 7th grade, Unit 6, Lesson 15. For each inequality, decide whether the solution is represented by x is less than 4.5 or x is greater than 4.5. A. We need to multiply negative 6 times everything inside the parentheses. Negative 6 times x and negative 6 times negative 0.5. On the left side of the inequality, we still have negative 24. But on the right side of the inequality, we now have negative 6x plus 3. The next step, we need to subtract 3 from both sides of the inequality sign. Negative 24 minus 3 is negative 27, and on the right-hand side, we're left with negative 6x. Next, we need to divide both terms by a negative 6. Since we're dividing by a negative, that means we need to switch the inequality sign. Negative 27 divided by negative 6 is a positive 4.5. And negative 6x divided by negative 6 is positive 1x, or x. This means that x is greater than 4.5. B. The first thing we need to do is subtract 6 from both sides of the inequality sign. That leaves us with negative 8x is greater than negative 36. Next, we need to divide both sides by negative 8. Since we're dividing by a negative, we need to switch the inequality sign. X is less than 4.5. C. Just like A, we need to use the distributive property. Negative 2 times everything inside the parentheses. On the right-hand side of the inequality, we still have negative 15.4. And on the left side of the inequality, we have negative 2 times 3.2, and we have negative 2 times x. Plus a negative 2 times 3.2 is plus a negative 6.4. The next step, we need to add 6.4 to both sides of the inequality sign. That leaves us with negative 2x on the left side of the inequality sign, and negative 9 on the right-hand side of the inequality sign. The last step, we need to divide both sides by negative 2. Since we're dividing by a negative, we need to switch the inequality sign. X is greater than 4.5. Problem number 5, from 7th grade, Unit 4, Lesson 2. A runner ran 2/3 of a 5-kilometer race in 21 minutes. They ran the entire race at a constant speed. A. How long did it take to run the entire race? Imagine that this circle represents the entire race, and the race is 5 kilometers. If you divide the race into thirds, 3/3 would represent the whole race. The information tells us that 2/3 of the race has been completed and it took 21 minutes. If 2/3 equals 21 minutes, then 1/3 would be half of 21. 21 divided by 2 is 10.5, so each third is worth 10.5. When the whole race is completed, that means that all 3/3 of the race would be completed, so we can multiply 3 times 10.5. The entire race would take 31.5 minutes. B. How many minutes did it take to run 1 kilometer? 31.5 minutes divided by 5 kilometers equals 6.3. That means it would take 6.3 minutes to run 1 kilometer at this constant speed. Problem number 6 from 7th grade Unit 6 Lesson 12. Jada, Elena, and Lynn walked a total of 37 miles last week. Jada walked 4 more miles than Elena, and Lynn walked 2 more miles than Jada. The diagram represents this situation. Find the number of miles that they each walked. Explain or show your reasoning. M plus M plus M plus 4 plus 4 plus 2 equals 37. Now that we've started to write an equation, let's collect like terms. 3m plus 10 equals 37. To solve for m, we got to get it by itself, so let's subtract 10 from both sides of the equal sign. That leaves us with 3m equals 27. To turn that 3m into just 1m, we need to divide both sides by 3. 3m divided by 3 and 27 divided by 3. That leaves us with 1m, or m, equals 9. Since Elena walked m miles, that means that Elena walked 9 miles. Jada walked m plus 4, which is 9 plus 4, or 13 miles. Lynn walked m plus 4 plus 2, or 9 plus 6, which is 15 miles. Problem number 7, from 7th grade Unit 6, Lesson 19. Select all the expressions that are equivalent to negative 36x plus 54y minus 90. Expression A. Use the distributive property and multiply negative 9 times 4x, and multiply negative 9 times negative 6y, and multiply negative 9 times negative 10. The expression simplifies to negative 36x plus 54y plus 90 instead of minus 90, so don't select A. B. After using the distributive property and multiplying negative 18 times all 3 terms, this expression is equal to negative 36x plus 54y minus 90, so do select B. C. After multiplying all 3 terms by negative 6, expression C is equivalent to negative 36x minus 54y plus 90. So do not select C. D. After multiplying 18 times all 3 terms inside the parentheses, expression D has a value of negative 36x plus 54y minus 90. So you can select D. E. After multiplying negative 2 times all 3 terms inside the parentheses, expression E has a value of negative 36x plus 54y minus 90. So you can select expression E. After multiplying a 2 times all 3 terms inside the parentheses, expression F has a value of negative 36x plus 108y minus 180. So do not select expression F. Now's a good time to subscribe if you haven't already. You can watch the next lesson. Thanks for watching, and I'll see you next time. 7th grade Unit 7, Lesson 6, Building Polygons, Part 1, Illustrative Mathematics. Problem number 1. A rectangle has side lengths of 6 units and 3 units. Could you make a quadrilateral that is not identical using the same 4 side lengths? If so, describe it. That's simple. You can take the rectangle and tilt it. The side lengths are still the same, but it's not identical to the original rectangle. Problem number 2. Come up with an example of 3 side lengths that cannot possibly make a triangle, and explain how you know. I could use 1 inch, 1.5 inches, and 0.5 inches, and it doesn't make a triangle because 2 of the side lengths are too short to touch one another. Problem number 3 from 7th grade Unit 7, Lesson 3. Find x, y, and z. That means they want us to find the missing measure for angles x, y, and z. These two angles are directly across from one another. They're called vertical angles, and vertical angles have the same angle measure. That means that angle x is 64 degrees. These two angles are also vertical angles, so angle y is 18 degrees. Z is a little bit trickier because its vertical angle is missing its measure. Angles z, x, and 18 degrees are along a straight line, so we know that the sum of those 3 angles will be 180 degrees. Z plus 64 plus 18 equals 180. 64 plus 18 is 82, so we can rewrite it as z plus 82 equals 180. To solve for z, we need to subtract 82 from both sides of the equal sign. 82 minus 82 is 0, and 180 minus 82 is 98. So angle z is 98 degrees. Problem number 4 from 7th grade Unit 7, Lesson 1. How many right angles need to be put together to make each of the following angles? Here's just one right angle, and a right angle is 90 degrees. Here's 2 right angles. 90 plus 90 equals 180. So B, 180 degrees, is made up of 2 right angles. And this straight angle is also made up of 2 90-degree angles. 3 right angles, or 90 times 3, is 270. So C, 270-degree angle, is made up of 3 90-degree angles, or 3 right angles. Add a 4th right angle, and you have 90 times 4, which is 360. So A, 360 degrees, is made up of 4 right angles. Problem number 5, from 7th grade Unit 6, Lesson 8. Solve each equation. First, we need to multiply the term on the outside of the parentheses by all the terms on the inside of the parentheses. 1/7 times x plus 1/7 times 3/4. You can rewrite this as 1/7 x plus 3/28 equals 1 over 8. To get x by itself, we need to subtract 3/28 from both sides of the equal sign. For 1/8 minus 3/28, I need to find a common denominator. I think I'll use 56. So 7 times 8 is 56, and 7 times 1 is 7. So that turns into 7 over 56. And 28 times 2 is 56, and 3 times 2 is 6. 7 56 minus 6 56 is 1 56. We need to multiply both sides by the reciprocal of 1/7, and that's 7 over 1. So on the left side, we have 1x, or x, and on the right-hand side, we have 1 over 8. So x equals 1/8. Again, we need to multiply the term on the outside of the parentheses by both terms on the inside of the parentheses. 0.6 times w plus 0.6 times 0.4. 0.6 times 0.4 is 0.24, so we can rewrite this as 1.5 equals 0.6w plus 0.24. To get the term with the w by itself, we need to subtract 0.24 from both sides of the equal sign, which leaves us with 1.26 equals 0.6w. To make it just 1w, we need to divide both sides by 0.6. W equals 2.1. Multiply the terms inside the parentheses by 3/4. 3/4 times z plus 3/4 times 2/3. 3/4 times 2/3. We can cross cancel, and that's worth 1/2, so we can rewrite this as 9/2 equals 3/4 z plus 1/2. To get the z by itself, we need to subtract 1/2 from both sides of the equal sign. 9/2 minus 1/2 equals 8/2. 1/2 minus 1/2 equals 0, so this can be rewritten as 8/2 equals 3/4 z. To make that 1z, we need to multiply both sides by the reciprocal of 3/4, which is 4/3. When you multiply a number by its reciprocal, the answer is always 1. So here on the right-hand side, we end up with 1z, or z, and on the left-hand side, we end up with 16/3. So z equals 16/3. Again, we multiply all the terms on the inside of the parentheses by the number on the outside of the parentheses. 0.08 times 7.97 plus 0.08 times v equals 0.832. To get the v alone, we need to subtract 0.6376 from both sides of the equal sign. And to make that 1v, we need to divide both sides by 0.08. So now we have 1v, or v, equals 2.43. Problem number 6, from 7th grade, Unit 4, Lesson 3. A. You can buy 4 bottles of water from a vending machine for $7. At this rate, how many bottles of water can you buy for $28? If you get stuck, consider creating a table. The information tells us that you can buy 4 bottles of water for $7. And they'd like to know how many bottles of water you can buy for $28. Since 28 is 4 times larger than 7, then you can buy 4 times as many water bottles. 4 times 4 is 16. So with $28, you can buy 16 bottles of water. B. It costs $20 to buy 5 sandwiches from a vending machine. At this rate, what is the cost for 8 sandwiches? If you get stuck, consider creating a table. The information tells us that you can buy 5 sandwiches for $20. They'd like to know what is the cost for buying 8 sandwiches. 5 times 4 is 20, or 20 divided by 5 is 4, so it's $4 per sandwich. 8 sandwiches times $4 per sandwich equals $32. So to buy 8 sandwiches, it would cost $32. Subscribe to my channel and watch the next lesson. Thanks for watching, and I'll see you next time. Seventh grade, Unit 7, Lesson 7, Building Polygons, Part 2, Illustrative Mathematics. Problem number 1. In the diagram, the length of segment AB is 10 units, and the radius of the circle centered at A is 4 units. Use this to create 2 unique triangles, each with a side length of 10 and a side length of 4. Label the sides that have the length of 10 and 4. The information tells us that the length of segment AB is 10 units and the radius is 4 units. Here's 2 triangles. Let's look at the top triangle, and since the radius is 4 units, this side length highlighted in yellow would be 4 units. And since the length of segment AB is 10 units, this line segment would be 10 units. Connect the ends with a straight line to represent the third side length. Now let's look at the bottom triangle. Since the radius is 4 units, this side length would be 4 units. Since line segment AB is 10 units, this line would be 10 units. And connect the open ends by drawing a straight line to represent the third side length. Problem number 2. Select all the sets of 3 side lengths that would make a triangle. First, let me give you an idea about how you would know if 3 sets of side lengths would form a triangle. Take the longest side length first. Let's imagine that this longest side length is 4 inches. The sum of the other 2 side lengths must be greater than 4 inches. If the sum was equal to 4 inches, it couldn't form a triangle. Here's an example. 3 plus 1 is 4. When these lines finally meet, they just form a 4-inch line. In order for these 2 side lengths to meet and not form a straight line, in other words, forming the other 2 sides of a triangle, their sum has to be greater than the largest side length, or in this case, their sum has to be greater than 4 inches. Here's an example, 3 plus 2, that's 5 inches, and when they meet, it doesn't form a straight line, it forms a triangle. Let's use that strategy for A. 8 is the largest side length, so 3 plus 4 needs to be greater than 8. Is 3 plus 4 greater than 8? No. 3 plus 4 is 7, and 7 is less than 8, so that's not going to form a triangle. Easy way to do it, looking at these 3 side lengths. 3 plus 4 is 7, and 7 is less than 8, so it won't form a triangle. Let's try B. Here's a look at a triangle that has a side length of 6, 7, and 12, and as you can see, it is a triangle. Remember, 6 plus 7 is 13, which is greater than 12. These 3 side lengths would form a triangle. C. The longest side length is 13, so the other 2 side lengths need to have a sum that's greater than 13. 5 plus 11 is 16, and 16 is greater than 13. So these 3 side lengths will form a triangle. D. 4, 6, and 12. 12 is the longest side length, so 4 plus 6 needs to be greater than 12. And since 4 plus 6 is 10, and 10 is less than 12, the side lengths for D will not form a triangle. E. 4, 6, and 10. 10 is the largest side length, so 4 plus 6 needs to be greater than 10. Since 4 plus 6 is equal to 10, the side lengths for E will not form a triangle. Problem number 3. Based on signal strength, a person knows their lost phone is exactly 47 feet from the nearest cell tower. The person is currently standing 23 feet from the same cell tower. What is the closest the phone could be to the person? What is the furthest their phone could be from them? Here's an illustration of the phone tower, the person, and their cell phone. We know that the lost phone is exactly 47 feet from the nearest cell tower, and we know that the person is currently standing 23 feet from the same cell tower. The expression 47 minus 23 will tell us the closest the phone could be to the person. Since 47 minus 23 equals 24, we know that the closest the cell phone could be to that person would be 24 feet. What is the furthest their phone could be from them? Remember, the person knows that the lost phone is exactly 47 feet from the nearest cell tower. And we know that the person is currently standing 23 feet away from the same cell tower. So the expression 47 plus 23 will tell us the furthest the phone could be from the person. Since 47 plus 23 equals 70, we know that the furthest the phone can be from that person is 70 feet. Problem number 4. From 7th grade, Unit 7, Lesson 2. Each row contains the degree measures of 2 complementary angles. Complete the table. Complementary angles add up to 90 degrees. So we know that 90 minus the given measure will give us the unknown measure. So 90 minus 80 equals the unknown measure. 90 minus 80 is 10. A 10-degree angle would be a complementary angle to an 80-degree angle. Let's do the next one. 90 degrees minus 25 degrees equals 65 degrees. So an angle of 65 degrees is a complementary angle to an angle of 25 degrees. Let's do the next one. 90 minus 54. That equals 36. That means a 36-degree angle would be complementary to a 54-degree angle. Let's do the last one. They've given us an unknown measure of x. So we'll just do 90 degrees minus x, or 90 minus x. The complementary angle to x is 90 minus x. Problem number 5, from 7th grade, Unit 7, Lesson 1. Here are 2 patterns made using identical rhombuses. Without using a protractor, determine the value of A and B. Explain or show your reasoning. First, let's see how many angle A's can fit in a full circle, because we know a full circle is 360 degrees. 6 angle A's in a full circle, or 6 angle A's in 360 degrees. So 360 divided by 6 means that each of the angle A's is 60 degrees. And this information shows us that 2 A's plus 2 B's equals 360 degrees. Since we know that the 2 A's are each worth 60, then 2 A's would be worth 120. We can write the equation 120 plus 2b equals 360. Next, solve for b by subtracting 120 from both sides of the equal sign. Now we're left with 2b equals 240. Let's make it 1b by dividing both sides by 2. Now we're left with 1b, or b, equals 120. So we know that the angle for b is 120 degrees. Problem number 6, from 7th grade, Unit 4, Lesson 3. Mai's family is traveling in a car at a constant speed of 65 miles per hour. A. At that speed, how long will it take them to travel 200 miles? We can make a table and put miles on one side and hours on the other. The car is traveling 65 miles in 1 hour. 65 divided by 65 equals 1. When they're traveling for 200 miles, we can do 200 divided by 65 to figure out how many hours it'll take them to travel 200 miles. 200 divided by 65 equals 3.07. So it should take them 3.07 hours to travel 200 miles. B. How far do they travel in 25 minutes? Let's go back to our table. Now we need to put 25 minutes in the hours side. But remember, it's the hours side. Since there's 60 minutes in an hour, we can say that 25 minutes can be represented as 25 out of 60, or 25 over 60. We need to multiply 25 over 60 times 65 to figure out how far or how many miles they can travel in 25 minutes. 25 over 60 times 65 equals 27.1. So that means that they can travel 27.1 miles in 25 minutes. Be sure to subscribe to my channel if you haven't already, and you can watch the next lesson. Thanks for watching, and I'll see you next time.
7th grade, Unit 7, Lesson 8. Triangles with 3 common measures. Illustrative Mathematics Practice Problems. Problem number 1. Are these 2 triangles identical? Explain how you know. Rotate the triangles to get a better look at them so you can make a comparison. At first glance, they do look identical. However, the triangle on the left has the 95 degrees attached to the 12-unit side length, and the triangle on the right has the 70 degrees attached to the 12-unit side length. Therefore, they're 2 different triangles. Problem number 2. Are these triangles identical? Explain your reasoning. Let's separate these 2 triangles so we can compare them better. It's obvious that these 2 triangles are different sizes, and that makes a difference. The side lengths on the triangle on the left are longer than the side lengths of the triangle on the right, so these triangles are not identical. Problem number 3. Tyler claims that if 2 triangles each have a side length of 11 units and a side length of 8 units, and also an angle measuring 100 degrees, they must be identical to each other. Do you agree? Explain your reasoning. This example shows that you can have 2 side lengths that are equal and an angle that is also equal and still have different triangles. So I disagree with Tyler's claim. Problem number 4, from 7th grade, Unit 5, Lesson 8. The markings on the number line are equally spaced. Label the other markings on the number line. The absolute value between -3 and 0 is 3 units. So the markings from left to right would be -9, -6, -3, 0, 3, 6, 9, 12, and 15. Problem number 5, from 7th grade, Unit 5, Lesson 9. A passenger on a ship dropped his camera into the ocean. if it is descending at a rate of negative 4.2 meters per second? How long until it hits the bottom of the ocean, which is at negative 1,875 meters? The camera's traveling negative 4.2 meters per second. So how many times does negative 4.2 go into negative 1,875? It goes in almost 446 and a half times. And that's equivalent to almost 7.5 minutes. So it would take the camera just less than 7.5 minutes to reach the ocean floor. Problem number 6. From 7th grade, Unit 4, Lesson 3. Apples cost $1.99 per pound. A. How much do 3 1/4 pounds of apples cost? At 1 pound for $1.99, we could multiply $1.99 times 3 1/4 pounds, or $1.99 times 3.25, which equals just about $6.47. So it would cost about $6.47 to buy 3 1/4 pounds of apples at $1.99 per pound. B. How much do X pounds of apples cost? Well, that would be $1.99 times X, which is $1.99X. C. Claire spent $5.17 on apples. How many pounds of apples did Claire buy? $5.17 divided by $1.99 equals approximately 2.6. So Claire was able to buy approximately 2.6 pounds of apples. Problem number 7 from 7th grade, Unit 3, Lesson 5. Diego has a glue stick with a diameter of 0.7 inches. He sets it down 3.5 inches away from the edge of his table, but it rolls onto the floor. How many rotations did the glue stick make before it fell off the table? Since the glue stick was rolling, we need to know the circumference of the glue stick. The circumference is pi times the diameter, which equals approximately 2.2 inches. Which means the circumference of the glue stick is approximately 2.2 inches. Since the glue stick was placed 3.5 inches away from the edge of the table, it was able to make approximately 1.6 rotations, because 3.5 divided by 2.2 is approximately 1.6. 7th grade, Unit 7, Lesson 9. Drawing Triangles, Part 1, Illustrative Mathematics. Practice problems. Problem number 1. Use a protractor to try to draw each triangle. Which of these triangles is impossible to draw? A. A triangle where one angle measures 20 degrees and another angle measures 45 degrees. Let's use this protractor to draw the first angle that measures 20 degrees. And now let's draw the next angle that measures 45 degrees. Next, we can slide this angle over and connect them to form the triangle that has one angle that measures 20 degrees and the other angle that measures 45 degrees. B. A triangle where one angle measures 120 degrees and the other angle measures 50 degrees. This angle's 120 degrees and this angle's 50 degrees. Now we can slide them over and see if we can fit them together to form a triangle. The green lines represent where these two lines would eventually meet to form a triangle. C. A triangle where one angle measures 90 degrees and another angle measures 100 degrees. Here's the 90-degree angle, and here's the 100-degree angle. You can see that these angles will never meet, so they won't form a triangle. The sum of two of the angles has to be less than 180 degrees. So this won't form a triangle. Problem number 2. A triangle has an angle measuring 90 degrees, an angle measuring 20 degrees, and a side that is 6 units long. The 6-unit side is in between the 90-degree and 20-degree angles. A. Sketch this triangle and label your sketch with the given measures. Here's the 90-degree angle. And here's the 20-degree angle, and this horizontal line at the bottom is the 6-unit side length between the 90-degree angle and the 20-degree angle. B. How many unique triangles can you draw like this? You can draw only one unique triangle with these exact measures as long as the 6-unit side length is between the 90-degree angle and the 20-degree angle. Problem number 3 from 7th grade, Unit 5, Lesson 13. A. Find a value for x that makes negative x less than 2x. Let's start with 0. When x is 0, negative x is 0, and 2x is 0. Let's plug in 1. When x is 1, negative x is negative 1, and 2x is 2. Negative 1 is less than 2. So when x is 1, negative x is less than 2x. B. Find a value for x that makes negative x greater than 2x. Let's try negative 1. So when x is negative 1, negative x is the opposite of negative 1, and 2x is 2 times negative 1. When x is negative 1, then negative x is greater than 2x, because the value for negative x would be 1, and the value for 2x would be negative 2, and 1 is greater than negative 2. Problem number 4 from 7th grade, Unit 5, Lesson 3. One of the particles in atoms is called an electron. It has a charge of negative 1. Another particle in atoms is a proton. It has a charge of positive 1. The overall charge of an atom is the sum of the charge of the electrons and the protons. Here is a list of common elements. Find the overall charge for the rest of the atoms on the list. Look at carbon. 6 negatives cancels out 6 positives, so the overall charge is 0. Look underneath it at aluminum. 10 negatives cancel out 10 positives, leaving 3 positives, so the overall charge is 3. Next, look at phosphide. There's more negatives than there are positives, so 15 positives will cancel out 15 of the negatives, and there'll be 3 negatives left over. So the overall charge for phosphide is negative 3. Look at iodide. There's 54 negatives and 53 positives. So there's 1 more negative. So the overall charge for iodide is negative 1. Let's look at the last one, tin. There's 50 negatives and 50 positives. That's a 0 balance. So the overall charge is 0. Problem number 5 from 7th grade, Unit 4, Lesson 3. A factory produces 3 bottles of sparkling water for every 7 bottles of plain water. If those are the only 2 products they produce, what percentage of their production is sparkling water? What percentage is plain water? The information tells us for every 3 bottles of sparkling water, there are 7 bottles of plain water. That's a total of 10 bottles. 3 out of 10 is equivalent to 30 out of 100, which is 30%. So 30% of their production is sparkling water, and 70% of their production is plain water.
7th grade, Unit 7, Lesson 10. Drawing Triangles, Part 2. Illustrative Mathematics Practice Problems. Problem number 1. A triangle has sides of length 7 centimeters, 4 centimeters, and 5 centimeters. How many unique triangles can be drawn that fit that description? Explain or show your reasoning. You can draw only one unique triangle using those same 3 measures. Once you have the 7 centimeters and the 4 centimeters side lengths connected, the only other side length that would fit would be a 5 centimeter side length. Here's an example. Draw the side length 7 centimeters, and then on one end of that side length, draw a 4 centimeter radii, and on the other end of that side length, draw a 5 centimeter radii. The area where those 2 circles meet is where the other 2 side lengths will meet. And those side lengths will be the same length as the 2 radii, 4 centimeters and 5 centimeters. Problem number 2. A triangle has one side that is 5 units long and an adjacent angle that measures 25 degrees. The 2 other angles in the triangle measure 90 degrees and 65 degrees. Complete the 2 diagrams to create 2 different triangles with these measurements. I decided to use 2 triangles that are mirror images of themselves. each with 90 degrees, 25 degrees, 65 degrees, and the 5-unit side length. Problem number 3. Is it possible to make a triangle that has angles measuring 90 degrees, 30 degrees, and 100 degrees? If so, draw an example. If not, explain your reasoning. No, because if you draw a 90-degree angle on the end of a side and a 100-degree angle on the other end of the same side, the other two sides will never meet to form a triangle. Remember, the sum of all three angles of a triangle must equal 180 degrees. So for this example, 90 degrees plus 30 degrees plus 100 degrees is well over 180 degrees. Problem number 4. From 7th grade, Unit 7, Lesson 2. Segments CD, AB, and FG intersect at point E. Angle FEC is a right angle. Identify any pairs of angles that are complementary. Angles FEB and DEB are complementary because the sum of all their angles is 90 degrees, which forms a right angle. And angles CEA and AEG are also complementary angles because they also form a 90-degree angle, or right angle. Problem number 5. From 7th grade, Unit 5, Lesson 15. Match each equation to a step that will help solve the equation for x. For equation A, we need to divide both sides by 3 to make 1x. And that's the same thing as multiplying both sides by 1/3. For equation B, we need to add 3 to both sides. For equation C, we need to multiply both sides by -3. For equation D, we need to multiply both sides by -1/3 to make a positive 1x. For equation E, we need to add 1/3 to each side, so we have a positive 1x. For equation F, we need to add -3 to each side, or subtract 3 from each side, so that we'll have x all by itself. For equation G, we need to multiply both sides by 3, so we'll have positive 1x by itself. For equation H, we need to add -1/3 to both sides, or subtract 1/3 from each side, so that we'll have a positive x by itself. Problem number 6, from 7th grade, Unit 4, Lesson 8. A. If you deposit $300 in an account with a 6% interest rate, how much will be in your account after 1 year? That's $300 with a 6% interest rate, or $300 times 0.06, and that's for 1 year. That would be $18 worth of interest in 1 year. So $300 plus $18 equals $318. B. If you leave this money in the account, how much will be in your account after 2 years? To include the second year, now we can do $318 times 0.06 to see how much interest we earn in the second year. That would be $19.08. So let's add the $318 from the first year to $19.08. That's the interest made in the second year, for a total of $337.08. Seventh grade Illustrative Mathematics, Unit 7, Lesson 11, Slicing Solids. Problem number 1. A cube is cut into 2 pieces by a single slice that passes through points A, B, and C. What shape is the cross section? Here's the slice through points A, B, and C, and you can see that the cross section is in the shape of a rectangle, just like this green face is a rectangle. Problem number 2. Describe how to slice the 3-dimensional figure to result in each cross section. Slice parallel to a face, and if you looked at it straight on, the cross section would look like this. Slice perpendicular to a face, and if you looked at it straight on, the shape of the cross section would be a trapezoid, just like this cross section. Problem number 3. Here are 2 3-dimensional figures. Describe a way to slice one of the figures so that the cross-section is a rectangle. Slice parallel to a rectangular face, and you can see that the cross-section is in the shape of a rectangle. Number 4. Each row contains the degree measures of two supplementary angles. Complete the table. The sum of two supplementary angles is 180 degrees. 80 degrees plus 100 degrees equals 180 degrees. 25 degrees plus 155 degrees equals 180 degrees. 119 degrees plus 61 degrees equals 180 degrees. When the measure of an angle is x, or an unknown measure, we can find the measure of its supplement angle by subtracting x from 180. Problem number 5. 2 months ago, the price in dollars of a cell phone was C. A. Last month, the price of the phone increased by 10%. Write an expression for the price of the phone last month. 1C, or C, represents the price of the phone 2 months ago, and this month the price increased by 10%, so we need to add 10% of the price of the phone from last month. Since 10% of 1 is 1/10, we need to add 1/10 to 1C, so we can start with 1C plus 1/10 C. The expression that represents the price of the phone after the 10% increase is 1.1 C. B. This month, the price of the phone decreased by 10%. Write an expression for the price of the phone this month. Remember, this month, the price of the phone decreased by 10%. We need to start with the price of the phone from last month. That's 1.1 C. And then we need to subtract 10% of 1.1 C. Since 10% of 1.1 C is 0.11 C, then we can write the expression 1.1 C minus 0.11 C, and that is 0.99 C. So the expression that represents the price of the phone this month is 0.99 C. C. Is the price of the phone this month the same as it was 2 months ago? Explain your reasoning. No. The phone is cheaper this month because 0.99 times C is less than 1 times C. Seventh grade Illustrative Mathematics, Unit 7, Lesson 12, Volumes of Right Prisms. Problem number 1, A. Select all the prisms. B. For each prism, shade one of its bases. Remember, prisms have two bases that are parallel to one another. E. The pyramid shape does not have two bases that are parallel to one another. Problem number 2. The volume of both of these trapezoid prisms is 24 cubic units. Their heights are 6 and 8 units as labeled. What is the area of a trapezoid base of each prism? The information tells us that their volumes are 24 cubic units. To find the area of the trapezoid's base, we can divide the volume of the trapezoid by its height. That would be 24 divided by 6, which is 4. So the area of the trapezoid base would be 4 square units. The height of the prism on the right is 8 units. So we can do 24 divided by 8, which is 3. So the area of the trapezoid base for this prism is 3 square units. Problem number 3 from 7th grade, Unit 7, Lesson 2. Two angles are complementary. One has a measure of 19 degrees. What is the measure of the other? Since the sum of two complementary angles is 90, we can subtract 19 from 90 to find the missing measure. 90 minus 19 is 71. So the missing measure, or the measure of the other angle, is 71 degrees. Problem number 4 from 7th grade, Unit 7, Lesson 2. Two angles are supplementary. One has a measure that is twice as large as the other. Find the two angle measures. Since the sum of two supplementary angles is 180 degrees, and the information tells us that one measure is twice as large as the other, we can write 2x plus x equals 180 degrees. because 2x is twice as large as 1x. 2x plus 1x is 3x. In this case, 3x equals 180 degrees. Divide both sides of the equal sign by 3 and 1x, or x, equals 60 degrees. The measure of one of the angles is 60 degrees. Since the other angle is twice as large, then the other angle is 120 degrees. So the measures of these two supplementary angles are 120 degrees and 60 degrees. Problem number 5 from 7th grade, Unit 6, Lesson 22. Match each expression in the first list with an equivalent expression from the second list. Expression A has 7 times x, which would be 7x. It also has a minus x, which is the same as minus 1x. 7x minus 1x is 6x. So far it matches with expression number 2 on the second list. Back to expression A. 7 times 2 is 14, and 14 plus 3 is 17. So it is a match with expression number 2, 6x plus 17. Take a look at expressions B and 3. 6x plus 4x is 10x, just like 2 times 5x is 10x. And then positive 3 and positive 5 is a positive 8, just like 2 times positive 4 is a positive 8. So B and 3 are a match. Take a look at expression C. It has 3/5 x and a negative 2/5 x. That's like 3/5 x minus 2/5 x, which equals 1/5 x, which matches the 1/5 x in the expression for number 1. Expression C also has minus 7 and minus 3, which is minus 10, which matches the negative 10 or minus 10 in expression 1. So expressions C and 1 are a match. Take a look at expressions D and 5. They both have an 8x, so far they're a match. And they both have a minus 5, a plus 4, and a minus 9. So expressions D and 5 are a match. Now look at expressions E and 4. E has a 24x, and 4 has a 12 times 2x, which is equivalent to 24x. And expression E has a positive 36, and expression 4 has a 12 times a positive 3, which is also equivalent to positive 36. So expressions E and 4 are a match. Problem number 6 from 7th grade, Unit 4, Lesson 8. Claire paid 50% more for her notebook than Priya paid for hers. Priya paid X for her notebook and Claire paid Y dollars for hers. Write an equation that represents the relationship between Y and X. It states that Claire paid 50% more for her notebook than Priya paid for hers. Since Priya is represented with an X, we can say that Claire paid 100% of the price of X plus another 50% of the price of X. So Claire paid 150% of X, which is the same as paying 1.5 times X, or 1.5x. So the equation would be Y equals 1.5x. Please take a moment to like the video and subscribe. I appreciate it. We'll see you next time.
7th grade Illustrative Mathematics, Unit 7, Lesson 13, Decomposing Bases for Area. Problem number 1. You find a crystal in the shape of a prism. Find the volume of the crystal. The point B is directly underneath point E, and the following lengths are known. From A to B is 2 millimeters. From B to C is 3 millimeters. From A to F is 6 millimeters. From B to E is 10 millimeters. From C to D is 7 millimeters. And from A to G is 4 millimeters. Think of this side as the base of the prism. Now think of this side as two separate trapezoids. 6 plus 10 is 16. 16 divided by 2 is 8. In other words, the average length of these two sides is 8 millimeters. So we can treat this like a rectangle that's 8 millimeters by 2 millimeters. 8 times 2 is 16. So the area of this shape is 16 millimeters squared. And we'll use that to help us find the volume of the crystal. Let's do the same thing to the trapezoid on the right. 10 plus 7 is 17. 17 divided by 2 is 8.5 or 8.5. So we can treat this like a rectangle that's 8.5 millimeters by 3 millimeters. 8.5 times 3 is 25.5 or 25.5. We can add these two areas together. 16 plus 25.5 equals 41.5 or 41.5. Now to find the volume of the crystal, we need to multiply the area of the base times the height. So 41.5 times 4. 41.5 times 4 is 166. So the volume of this crystal is 166 cubic millimeters, or 166 millimeters to the third power. Problem number 2. A rectangular prism with dimensions 5 inches by 13 inches by 10 inches was cut to leave a piece as shown in the image. What is the volume of this piece? What is the volume of the other piece not pictured? The piece not pictured is going to have a slightly smaller volume compared to the piece pictured. The difference in volume for these two pieces is represented here in blue. I'm going to turn these into 3 separate shapes, the blue piece on the bottom and then the yellow piece and the red piece that are the same shape and volume. First, let's find the volume of this red piece. We'll use these as the bases. However, we need to account for this 1-inch section. We need to remove that inch from 13 inches, making it 12 inches. To find the area of this triangle, we multiply 12 times 5, and since it's a triangle, we divide it by 2. 60 divided by 2 is 30. Now we need to multiply the area of the base by the height of the prism. 30 times 10, that's 300. So the volume of the piece that's not pictured is 300 cubic inches, or 300 inches to the third power. Because the piece that's not pictured is the same size as the piece that is pictured, except for this little blue section. To find the volume of the piece that is pictured, we just have to add the volume of this blue section to 300 inches to the third power. 5 times 1 times 10, that's 50 inches to the third power. So the volume of the entire rectangular prism that's shown is 350 inches to the third power. Problem number 3, from 7th grade, Unit 7, Lesson 9. A triangle has one side that is 7 centimeters long and another side that is 3 centimeters long. A. Sketch this triangle and label your sketch with the given measures. If you are stuck, try using a compass or cutting some straws to these two lengths. Here's one example of what this triangle could look like. B. Draw one more triangle with these measures that is not identical to your first triangle. Here's another look at a triangle that you could draw using these same measures. C. Explain how you can tell they are not identical. The triangle on the left has a hypotenuse that's 7 centimeters long, and the triangle on the right does not have a hypotenuse that's 7 centimeters long. Plus, If you were to place these triangles on top of each other, they don't match up. Problem number 4, from 7th grade, Unit 7, Lesson 4. Select all equations that represent a relationship between angles in the figure.
This 90-degree angle minus 30 degrees leaves the angle with B degrees. So I would select A. B. The 30-degree angle plus the B degree angle does equal the A degree angle plus the C degree angle. That's because the B degree angle is a vertical angle of the A degree angle, and the C degree angle is also a vertical angle of the 30-degree angle. So I would select B. C. The A degree angle plus the C degree angle plus the 30-degree angle plus the B degree angle equals 180 degrees. And that's true, because 90 degrees plus 90 degrees equals 180 degrees. I would select C. D. Angle A equals 30 degrees. That's not true because the A degree angle is obviously much larger than the 30-degree angle, so I would not select D. E. A equals C equals 30. I would not select this one because those angles are not the same size as each other. F. 90 plus A plus C equals 180. Well, that's true because angle A plus angle C equals 90 degrees, and 90 degrees plus 90 degrees equals 180 degrees. So I would select F. Problem number 5, from 7th grade, Unit 4, Lesson 9. A mixture of punch contains 1 quart of lemonade, 2 cups of grape juice, 4 tablespoons of honey, and 1/2 gallon of sparkling water. Find the percentage of the punch mixture that comes from each ingredient. Round your answers to the nearest 0.1%. Hint: 1 cup equals 16 tablespoons. Let's make each of these mixtures the same unit measure. Let's use cups. 1 quart of lemonade, that would be equal to 4 cups. 4 tablespoons of honey, that would be equal to 1/4 of a cup. We have 8 cups of sparkling water. Next, add up all the cups. 4 plus 2 plus 1/4 plus 8. That equals 14 1/4 cups, or 14 25/100 cups. 4 cups of lemonade out of 14 1/4 cups. That would be 4 divided by 14.25. So that's approximately 28.1% lemonade. 2 cups of grape juice divided by 14.25 is approximately 14% grape juice. 1/4 of a cup of honey divided by 14.25 is approximately 1.8% honey. 8 cups of sparkling water divided by 14.25 is approximately 56.1% sparkling water. Seventh grade Illustrative Mathematics, Unit 7, Lesson 14. Surface area of right prisms. Problem number 1. Edge lengths are given in units. Find the surface area of each prism in square units. This side, or base, has the dimensions 5 by 8, and so does the one directly underneath it. The surface area of each of these is 40 units squared. The dimensions for these sides are 5 by 10, so the surface area for each of these sides will be 50 units squared. The dimensions for these last two sides are 8 by 10, so each of these two sides will have the surface area of 80 units squared. Add up each of these surface areas and you'll have the surface area for the entire prism. The surface area for prism A is 340 units squared. Prism B. These triangular bases have the dimensions 8 by 6, but remember they're triangles. If we were to find the surface area of each triangle, we would do 1/2 times 8 times 6, or 1/2 of 8 times 6. However, there are two triangles, so we can treat these two triangles the same way we can treat one rectangle. 8 times 6 is 48. So the two triangles combined have a surface area of 48 units squared. The dimensions for this side are 6 by 15. So the surface area for this side would be 90 units squared. The dimensions for this side are 8 by 15. So the surface area for this side would be 120 units squared. And finally, the dimensions for this last side are 10 by 15. So the surface area for this side would be 150 units squared. Add all the surface areas for each of the sides, and you'll have the surface area for the prism. The surface area for prism B is 408 units squared. Prism C. The dimensions for these two sides are 5 by 4. Each of their surface areas would be 20 units squared. The dimensions for these two sides are 5 by 13. Each of their surface areas are 65 units squared. And the dimensions for these sides are 4 by 13. So their surface areas will be 52 units squared. Add up the surface areas for each of the sides, and you'll have the surface area for the entire prism. The surface area for prism C is 274 units squared. Prism D. This side has the dimensions 5 by 8, so its surface area would be 40 units squared. This side has the dimensions 8 by 13, so its surface area is 104 units squared. The dimensions for this side are 8 by 12, so its surface area is 96 units squared. And finally, the top and bottom base, which is in the shape of a triangle. The dimensions are 5 by 12. We could figure out their individual surface area by multiplying half times base times height, or we could just treat these two triangles as one rectangle, which would be 5 times 12. The combined area of these two bases is 60 units squared. Add up all these surface areas, and you'll have the surface area for prism D, which is 300 units squared. Prism E. This prism has two sides that are 5 by 12, one side that's 6 by 12, and two triangular bases, each with a base of 6 units and a height of 4 units. Add up all of these surface areas, and you'll have the total surface area for prism E. The total surface area for prism E is 216 units squared. Problem number 2. Priya says no matter which way you slice this rectangular prism, the cross-section will be a rectangle. May says, I'm not so sure. Describe a slice that May might be thinking of. She might be thinking of making parallel slices, like these two examples. But May might be thinking about just slicing off a corner, like this example, and the cross-section is in the shape of a triangle rather than a rectangle. Problem number 3. B is the intersection of line AC and line ED. Find the measure of each of the angles. A. The measure of angle ABF. The information tells us that angle ABE is 110 degrees and angle EBF is 20 degrees. If we add those together, we can see that angle ABF is 130 degrees. B. The measure of angle ABD. I know that the measure of angle EBD is 180 degrees, and it tells us that angle ABE is 110 degrees. 180 degrees minus 110 degrees gives us the missing measure of angle ABD. So the measure for angle ABD is 70 degrees. C. The measure of angle EBC. We can use this information and see that ABC is 180 degrees, ABE is 110 degrees. It also tells us EBF is 20 degrees. 180 minus 110 minus 20 equals 50. That means angle FBC is 50 degrees. 50 degrees plus 20 degrees equals 70 degrees. So the angle for EBC is 70 degrees. D. The measure of angle FBC. Well, we just figured that out in the last one. 110 degrees plus 20 degrees plus 50 degrees equals 180 degrees. The measure of angle FBC is 50 degrees. E. The measure of angle DBG. We already figured out the measure for angle ABD, which is 70 degrees, and the measure for angle GBC is 65. So 180 degrees minus 70 degrees minus 65 degrees equals 45 degrees. So the measure of angle DBG is 45 degrees. Problem number 4. Write each expression with fewer terms. A. 12m minus 4m. 12m minus 4m is 8m. B. 12m minus 5k plus m. That's the same as 12m plus 1m, which is 13m. 13m minus 5k. C. 9m plus k minus 3m minus 2k. This minus sign goes to both the terms inside the parentheses. So 3m becomes negative 3m, and negative 2k becomes positive 2k. It's like saying the opposite of negative 2k. The opposite of negative 2k is positive 2k. Now we can combine like terms. 9m minus 3m is 6m, and 1k plus 2k is 3k. So the expression now reads 6m plus 3k. Problem number 5. A. Find 44% of 625 using the facts that 40% of 625 is 250 and 4% of 625 is 25. 44% is 40% plus 4%. The information tells us that 40% of 625 is 250 and 4% of 625 is 25. So we can add 250 and 25. We get 275. That means that 44% of 625 is 275. B. What is 4.4% of 625? 4.4% is 10 times smaller than 44%. So our answer is going to be 10 times smaller than 275. 4.4% of 625 is 27.5. C. What is 0.44% of 625? 0.44% is 100 times smaller than 44%. So our answer is going to be 100 times smaller than 275. 0.44% of 625 is 2.75. Be sure to like this video and subscribe to my channel. I appreciate it. I'll see you next time. Seventh grade Illustrative Mathematics, Unit 7, Lesson 15, Distinguishing Volume and Surface Area. Problem number 1. Here is the base of a prism. A. If the height of the prism is 5 centimeters, what is its surface area? What is its volume? Here's a three-dimensional model of what the prism might look like with a height of 5 centimeters. To find the surface area of this base, you'd multiply 8 times 5, which would get you 40 centimeters squared. Next, we need to subtract this small section that's 2 by 2. 2 times 2 is 4 centimeters squared. So 40 centimeters squared minus 4 centimeters squared gives us 36 centimeters squared for each of the two bases. For these two sides, the area would be 5 times 5, or 25 centimeters squared. The area of this side would be 8 times 5, or 40 centimeters squared. The area for these two sides would be 3 times 5, or 15 centimeters squared. The surface area for these three sides would be 2 times 5, or 10 centimeters squared. Now to find the total surface area for the entire prism, we have to add up all the surface areas for each of the sides and bases. 50 plus 40 plus 30 plus 30 plus 72. So the surface area for the entire prism is 222 centimeters squared. Next, we need to find the volume. 5 times 5 times 8 equals 200 centimeters cubed, and we need to subtract 2 times 2 times 5, or subtract 20 centimeters cubed. The volume of this prism is 180 centimeters cubed. B. If the height of the prism is 10 centimeters, what is its surface area? What is its volume? I know that the volume is going to double because the height doubled. So the volume would be 360 centimeters cubed. Now let's find the surface area. Let's take the information from the first problem and substitute the height with a 10. The base that I have pictured at the bottom would remain unchanged. And remember, there's two bases, a top and a bottom. The way the base is pictured right now, it's laying on one of its sides. So remember, if it were standing on its base, the height is doubled, changing from 5 centimeters to 10 centimeters in height. The surface area of the bases is unchanged, and we can add all the surface areas together, making the surface area of this new base 372 centimeters squared. C. When the height doubled, what was the percent increase for the surface area? For the volume, the larger surface area minus the smaller surface area will equal the increase. 372 minus 222 is 150. They're asking what was the percent increase. We need to figure out what percent 150 is of 222. You can do that by dividing. 150 divided by 222 shows that 150 is approximately 67.6% of 222. That was the percent increase for the surface area. Now we need to find the percent of increase for the volume. 360 minus 180 equals 180. So 180 divided by 180 shows that the percent of increase was 100%. Problem number 2. Select all the solutions where knowing the volume of an object would be more useful than knowing its surface area. I wouldn't choose A because determining the amount of paint needed to paint a barn has to do with the surface area of the barn. I would choose B because determining the monetary value of a piece of gold jewelry has to do with the volume of the gold jewelry. I would also select C because filling an aquarium with buckets of water has to do with the volume of the aquarium. I would not select D because deciding how much wrapping paper a gift will need has to do with the surface area of the gift. I would select situation E because packing a box with watermelons for shipping has to do with the volume of the box. I would not select situation F because charging a company for ad space on your race car has to do with the amount of surface area the ad takes up on the race car. And I would select situation G because measuring the amount of gasoline left in the tank of a tractor has to do with the volume of the gas tank of the tractor. Number 3. Han draws a triangle with a 50-degree angle, a 40-degree angle, and a side length of 4 centimeters as shown. Can you draw a different triangle with the same conditions? Sure. Here's a triangle with a 50-degree angle, a 40-degree angle, and a side length of 4 centimeters. Problem number 4. Angle H is half as large as angle J. Angle J is 1/4 as large as angle K. Angle K has measure 240 degrees. What is the measure of angle H? The information tells us that angle J is 1/4 of angle K, or 1/4 of 240 degrees. 240 divided by 4 is 60, so angle J is 60 degrees. It also tells us that angle H is half as large as angle J, So half of 60 degrees is 30 degrees. Angle H is 30 degrees. Problem number 5. The Colorado state flag consists of 3 horizontal stripes of equal height. The side lengths of the flag are in the ratio 2:3. The diameter of the gold-colored disc is equal to the height of the center stripe. What percentage of the flag is gold? The information tells us that the side lengths of the flag are in the ratio 2:3, which is the same as 3 to 4.5, which means I can use the height as 3 units and the width as 4.5 units. This will help me find the area. 3 times 4.5. The area of the flag is 13.5 units squared. The information tells us that the gold-colored disc is equal to the height of the center stripe, and we know that the center stripe is 1 unit tall. The area of the gold circle is pi times r squared. The radius is half the diameter. If the diameter is 1, then the radius is half, or 0.5. 0.5 squared, or 0.5 times 0.5, is 0.25. We can use 3.14 for pi, and pi times 0.25 is approximately 0.786. So that means that the area of the gold-colored disc is approximately 0.786 units squared. We need to find out what percentage of the flag is gold, or what percent of 13.5 units squared is 0.786. We can do that by dividing. 0.786 divided by 13.5 is approximately 0.0582, which is approximately 5.82%. That means that the gold-colored disc is approximately 5.82% of the surface area of the flag. Seventh grade Illustrative Mathematics, Unit 7, Lesson 16, Applying Volume and Surface Area. Problem number 1. A landscape architect is designing a pool that has this top view. A. How much water will be needed to fill this pool 4 feet deep? Deconstruct this top view. This section has the dimensions 11 by 1.5 and it's 4 feet deep. This section has the dimensions 9 by 10.5 and it's also 4 feet deep. And this last section that's in the shape of a triangle is 2 by 10.5 by 4, and since it's a triangle we need to divide it by 2. This gives you the volume for each of the 3 sections of the pool. Add them together and you know how much water will be needed to fill the pool 4 feet deep. This pool holds 486 cubic feet of water. B. Before filling up the pool, it gets lined with a plastic liner. How much liner is needed for this pool? We need to find the area for all 4 sides and the bottom of the pool. The dimensions for this side are 9 by 4 feet deep. For this side, 10.7 by 4 feet deep. By this little section, 1.5 by 4 feet deep. For this section, 11 by 4 feet deep. And this section, 12 by 4 feet deep. After we find the area for these walls, we need to find the area for the bottom of the pool. Let's find the area for the walls first and then come back to the bottom of the pool. Multiply to find the area for each of the walls, then add up each of their areas and you'll have the area for all the walls combined. The area for all these walls is 176.8 feet squared. And we'll add that to the area of the floor. To find the area of the floor, I'm going to treat this shape like a rectangle first, and then I'll subtract this little triangle sliver from the side. I'll use the dimensions 12 by 11, which gives me 132. And for the little triangle, I'll use the dimensions 2 by 10.5, which is 21. And remember, it's a triangle, so we have to divide it by 2. 21 divided by 2 is 10.5. I need to subtract this from 132, which gives me 121.5. Now all I have to do is add that to the area of the walls. They would need 298.3 square feet of plastic liner. C. Here are the prices for different amounts of plastic liner. How much will the plastic liner for the pool cost? I'm going to use this information to figure out how much 1 square foot of plastic liner costs. 25 divided by 25 equals 1, and $3.75 divided by 25 equals 15 cents. That means that you can get 1 square foot of liner for 15 cents. So we can figure out the price by multiplying 298.3 square feet of liner times 15 cents. The total cost for the pool liner would be $44.75. Problem number 2 from 7th grade, Unit 7, Lesson 13. Shade in the base of the trapezoidal prism. Be careful, the base is not the same as the bottom. I shaded in 2 bases. Find the area of the base you shaded. Because of the shape of the base, I'll make a rectangle and a triangle. The dimensions of the rectangle are 4 by 5. To find the dimensions of this triangle, I could subtract 5 from 8. 8 minus 5 is 3. So the base of the triangle is 3, and its height is 4. The area of the rectangle will be 5 times 4, which is 20. So 20 square units for the rectangle. And the area for the triangle will be half of 4 times 3, or 4 times 3 divided by 2. 12 divided by 2 is 6, so the area of the triangle is 6 square units. Add the 2 areas together, and the total area of the base is 26 units squared for 1 base. Find the volume of this trapezoidal prism. I'm going to treat it as 2 prisms, a rectangular prism and a triangular prism. The dimensions for the rectangular prism are 4 by 12 by 5. So we multiply 4 times 12 times 5. It has a volume of 240 units to the 3rd power, or 240 cubic units. We need to add that to the volume of the triangular prism. Since it's a triangular prism, we can treat it like a rectangular prism, but then we need to divide it by 2 because it's a triangular prism, which is half of a rectangular prism. It has dimensions 3 by 4 by 12, so we multiply 3 times 4 times 12. And then we'll cut that in half by dividing it by 2. The area of this triangular prism is 72 units cubed. Add them together and you'll find that the volume of this trapezoidal prism is 312 units cubed. Problem number 3 from 7th grade, Unit 4, Lesson 9. For each diagram, decide if y is an increase or a decrease of x. Then determine the percentage that x increased or decreased to result in y. Let's take a look at x. Notice that it's only the shaded blue part. The 3 shaded blue sections plus the white section on the right total the same length as y. You'll notice that the blue sections, x, is divided up into 3/3. The increase from x going to y is the same as one of the x's thirds. So the increase is equal to 1/3 of x. And 1/3 is equal to 33 1/3%. So the increase is 33 1/3% of x. B. Again, x is the blue shaded part, and there's 3/3 shaded in. Y is 5/3 the length of x. X going to y means that 3/3 went to 5/3. So we know that y is an increase of x. That's an increase of 2/3 of x. Y is an increase of 66 2/3% of x. C. This time y is smaller than x, so we know that it's a decrease, and it looks like it decreases 1/3 of x, and 1/3 is 33 1/3%. So y is a decrease of 33 1/3% of x. D. Y is smaller than x, so y is a decrease of x, and it looks like it decreased 2/3 of x. And 2/3 is 66 2/3%. So y is a 66 2/3% decrease of x. Problem number 4 from 7th grade, Unit 4, Lesson 10. Noah is visiting his aunt in Texas. He wants to buy a belt buckle whose price is $25. He knows the sales tax in Texas is 6.25%. A. How much will the tax be on the belt buckle? The price of the belt buckle, $25, times the tax rate, which is 0.0625. And that'll give you the tax on the belt buckle. B. How much will Noah spend for the belt buckle, including tax? Well, that would be the price of the belt buckle, $25, plus the tax. He would spend a total of $26.56. C. Write an equation that represents the total cost, C, of an item whose price is P. The total cost equals, or C equals, 1.0625 times P. The 1 represents one belt buckle times its price, P, and the 0.0625 represents the tax rate times the price of the item. I hope this helps, and thanks for watching. If you haven't already subscribed, please subscribe. I appreciate it. See you next time.